Tonight we'll be talking about perpendiculars and bisectors and perpendicular bisectors. So go ahead and title your notes, perpendiculars, bisectors. And a perpendicular bisector is just a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. So that's very important to know. It has to be at its midpoint. If it's at its midpoint, it's a bisector because it's splitting that segment or that plane or whatever it's going through in half. So those two sides would be congruent. So remember that. Now let's look at some of our theorems. So there's a perpendicular bisector theorem. It states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So it just means that if a point is on this bisector here in the segment, so right there, it won't let me mark on there, then these two are equal distance. So if CP is perpendicular bisector to AB, then CA and CB are also equal as well. The converse of the perpendicular bisector theorem is just the opposite. So if you know that DA and DB are equal and D lies on the perpendicular bisector of AB, that's how you would find that out. So if you know these two are equal and point D is at the end of it, you know it's on the perpendicular bisector of AB. So D is on CP, which is the perpendicular bisector of AB. The next bisector theorem is the angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So in this example, if the measurement of angle BAD, so this one in here, is equal to CAD, then DB and DC will therefore be congruent. So once again, if this angle is congruent with this angle and there's a bisector in it, then you know that BD and DC are congruent. The converse of the angle bisector theorem is this. If a point is in the interior of an angle and is equidistant from the sides of the angle, then it lies on the bisector of the angle. So if DB is equal to DC, then the angle of BAD and CAD will therefore be congruent. So measurement of BAD is equal to the measurement of CAD. A perpendicular bisector of a triangle is a line or ray or segment that is perpendicular to a side of the triangle at the midpoint of the side. So if down here, here's the side they're talking about, right there, and they're saying that it is perpendicular at the midpoint. So we know this guy is the midpoint. When three or more lines or rays or segments intersect in the same point, they are called concurrent lines. So for example, this line is concurrent with this and this line. The point of intersection of the lines is called the point of concurrency. The three perpendicular bisectors of a triangle are concurrent. The point of concurrency can be inside the triangle, on the triangle, or outside the triangle. So, for example, here are concurrent lines in the triangle. So in, and then this is the point of concurrency right there. These lines are concurrent right on the triangle. And here is that point of concurrency. And this one, the lines that are going through the triangle, are intersecting outside of the triangle, but they're still considered concurrent lines with that triangle. And this is our point of concurrency. The reason those are important is because we talk about finding the center, the circumcenter of the triangle. The circumcenter of the triangle is the point of concurrency, so where all those lines meet, of the perpendicular bisectors of a triangle. So they have to be perpendicular bisectors in order to be the circumcenter of the triangle. So an angle bisector of a triangle is a bisector of an angle of the triangle. So therefore, here's an angle bisector, here's an angle bisector, and here's an angle bisector. The point of concurrency of the angle bisectors, so right here, is called the incenter of the triangle. So that's the incenter of the triangle, and it always lies inside the triangle. The incenter has a special property. We may or may not talk about that in this lesson, but we can add the theorem, but we won't look at the proof yet. Okay, concurrency of angle bisectors of a triangle. The angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. So if we have PD here, so we have PD, that's an angle bisector. We have, or I'm sorry, P is the center and then it goes out to the end. So all of these lines connected to form an epicenter there. So you have PD, PE, and PF. And those are all equidistant from the sides of the triangle. So you have this one, and this one, and they're all equidistant from there. So all they did was they created a little circle, but they just went from their point straight out with a perpendicular bisector, and all of those would be equidistant. Okay, so tomorrow you'll be coming in and you'll be ready to work with bisectors.